Have you ever driven across a massive suspension bridge and wondered, how on earth is this thing not falling down? They seem to float so effortlessly, yet they carry thousands of cars, trucks, and buses every single day. It's one of the most incredible feats of modern engineering, and the secret behind it is both surprisingly simple and brilliantly complex. So, how do they hold up all that weight? The answer lies in those enormous steel cables stretching from one end to the other. Look closely, and you'll see they aren't just single, thick ropes. Each main cable is actually a bundle of thousands of individual steel wires, all twisted together. A single wire might seem thin, but when you combine them, you get a force of nature rope so strong it can support the weight of a small town. But strength alone isn't enough. These cables need to be anchored. At each end of the bridge, the cables are secured deep into massive blocks of concrete or solid bedrock. These are called anchorages, and their job is to resist the immense pulling force, or tension, that the weight of the bridge creates. Without these anchorages, the towers would simply be pulled inward, and the whole structure would collapse. Now, let's talk about those majestic towers that rise high above the water. They're not just for decoration. The towers act like giant pillars, and their primary role is to hold up the main cables. The weight of the bridge and all the traffic on it pulls down on the cables. This force is then transferred up to the tops of the towers and then pushed straight down into the ground through the tower foundations. This downward force is called compression. So, you have a beautiful dance between tension in the cables and compression in the towers. It's a perfect partnership. The roadway, or deck, where the cars actually drive, doesn't support itself. Instead, it hangs from the main cables. You can see smaller vertical cables, called suspender ropes or hangers, running from the main cable down to the deck. They are spaced out along the entire length of the bridge. When a car drives onto the bridge, its weight is immediately transferred from the deck, up through these hangers to the main cables, then across to the towers, and finally, safely into the ground. It's an incredibly efficient system for distributing weight. One of the most fascinating things about suspension bridges is their flexibility. They are designed to move when strong winds blow or when the temperature changes, causing the steel to expand or contract. The bridge can sway and flex slightly. This isn't a sign of weakness. It's a critical part of its strength. A rigid structure would crack and break under such stress. But a suspension bridge adapts, bending without breaking, which is what allows it to withstand extreme conditions, from gusty winds to even minor earthquakes. Think about the sheer scale of it. The Kashikaku Bridge in Japan, the world's longest suspension bridge, spans nearly 2.5 miles. Its cables contain enough wire to circle the Earth over 7 times. Every single day, tens of thousands of vehicles cross it, each weighing thousands of pounds, and the bridge handles it all with grace. It's a testament to centuries of learning, blending physics, materials science, and pure human ingenuity. So, the next time you find yourself gliding across a suspension bridge, take a moment to appreciate the incredible engineering at work. You're not just on a road, you're suspended in the air by a carefully balanced system of tension and compression. These bridges are more than just a way to get from one side to the other. They are symbols of connection, ambition, and our ability to overcome incredible challenges. Thanks for watching. If you found this as fascinating as I do, don't forget to hit that like button and subscribe for more deep dives into the world around us. See you in the next one.